All right, guys, so we're going to pick up with problems 14 and 15 because I realized yesterday when I was copying them over to the notes, I missed those two and we ended up skipping them. So we're going to start off with finding all the possible rational zeros. Now to find the rational zeros, it's our plus or minus p over q, where p is the factors of the constant term, and q is the factors of the leading coefficient. So we can look at 14 first. So factors of p and factors of q is what I would find first. So we'd find factors of 125, our constant term. So our first set is going to be 1 and 125. Now 2 doesn't divide into 125. 3 does not, because we'd add the terms together. 1 plus 2 is 3, and 3 plus 5 is 8. 3 is not divisible by 8, so 3 doesn't work. 4, if the last two terms are divisible by 4, 25 does not divide by 4. 4 doesn't work, but 5 does. We'd have 5 and 25. Then we move on to 6. 6 only works if 2 and 3 are both factors. Neither are. 6 doesn't work. Then we move to 7. 7 is not a factor. 8. 9 does not work. 10 doesn't work, because I think the next one is 15. Divided by 10 doesn't work. 25 divided by 11 doesn't work, and we're done there. 15 doesn't work either. And again, you could do these in a calculator. You can just take 125 divided by 2, 125 divided by 3, and keep going until whatever number you get out, so 11.36, meets up with the number you're dividing by. Because once those two meet, nothing else is going to work. You're just going to end up repeating. And what I mean by that is if we look at 125 divided by 12, well, the solution that we get is less than what we divided by, so the factors have met up. There's not going to be any more. So, incidentally, our only sets of factors are 1, 5, 25, and 125. Kind of nice. Can we look at the factors at 20? We have 1 and 20, 2 and 10, 4 and 5. Now to list all the possible factors, we have plus or minus p over q. I always start with the first value of q, which is 1. So we can do 1 divided by 1 is 1. 5 divided by 1. 25 divided by 1. And 125 divided by 1. Because it really just works out, we get plus or minus our factors of p. Now we do the same thing, but this time with 2. So we do 1 divided by 2, which would be plus or minus 1/2. Then we do 5 divided by 2, plus or minus 5/2. 25 divided by 2, plus or minus 25/2. And lastly, 125 divided by 2 is plus or minus 125 over 2. We'll do the same thing with 4. So we have 1 divided by 4 is 1/4. 5 divided by 4 is going to be plus or minus 5/4. 25 divided by 4 is plus or minus 25/4. And lastly, we have plus or minus 125 over 4. And we keep doing these one at a time, so we'll move on to 5 next. So we have 1 divided by 5 is plus or minus 1/5. However, what is 5 divided by 5? It is 1. We already have 1, yes? So we don't have to list it again. If it repeats, we don't have to list it more than once. 25 divided by 5 is 5. We already have it. 125 divided by 5 is going to be 25. We already have it. Since it didn't bring anything new, we just have plus or minus 1/5. then we can move on to 10. So the first one we'll have is plus or minus 1/10. We have 1 divided by 10. Now 5 divided by 10, 5 over 10 is the same as 1/2. We already have it listed, so we don't need to list it again. 25 divided by 10 does reduce, and it is 5/2. We have 5/2 listed. And lastly, 125 divided by 10 is going to reduce to 25/2. We have it, so we only have to list the 1/10. And lastly, with 20, so we'd have 1 over 20 plus or minus 1/20. 5 over 20 is going to reduce to 1/4. We already have it. 25 over 20 would reduce to 5/4. We have it. And 125 over 20 is going to reduce to 25/4. So these are all the possible rational zeros. And most likely the times where we won't have to list them all out is if there's a greatest common factor between the factors of P and whatever that value of Q is. If there's not, like 2 and 4, we have to list them all back out. Questions on either one of these here? We good with these two here? And 15 will have a lot less factors because 8 and 20 do have a lot of common factors between them. So a lot of stuff would reduce, especially when we get to 10, 20, and other numbers like that. We did these yesterday. So this is the next one here. Find the solution set of each inequality and graph on the number line. We can look at both of these here, but the main thing we're looking for is zeros. We're looking for zeros, especially with 18. We're trying to see what values of x will make this here be 0. And the reason we're looking for that is because the zeros is where it's going to cross the x-axis, where it's going to go from greater than 0 to less than, or less than to greater than. And there's different ways we can go about it, but we know we should have how many zeros? 4, because the degree is always equal to the number of zeros as long as we count repeated zeros. So we should have at least 4. Now, we could start off with our rational zeros theorem. List out all the rational zeros and test each one and go from there. We could also use Descartes' rule of signs to see how many positive and negative zeros we can have. Or it's the third minus 24x squared (35x) 385x. Thank you. That was probably going to take longer than it needed to. Now we get these zeros here. Yes? Now, some of them look nice, some of them do not. So we do definitely have a negative 0. Well, 7. Because we look back at the graph, 7 over here, we do have. It looks like it hits the x-axis but doesn't quite cross. So there's a good chance there's a multiplicity there. There's more than one 0 there. And we have one at negative 4. And now the intermediate value theorem. So if we look between the x values of -1 and 0, the y's go from negative to positive, positive, negative, which direction we're going, which means that there's a 0 between -1 and 0. So there's a 0 there. So we have -4, 7 for sure. So we know at those spots, we do have a 0. But we still need to find the last 0. So if we wanted to, so here it doesn't look like I included it. Here, myself a lot of space. Let's because I think at the very bottom of your page, you have a number line, yes? So there we can put a spot for -4, whatever the number is, and 7, because we know we'll have 3 spots on this number line. So we'll list those there. We'll come back to it when we find the other one. Now I can pick any one of these to go with first, so I can say -4. Numbers across the top are going to be 2 for x to the 4th, -19 for x cubed, -24 for x squared, 385 for x, and 196. We can bring down the 2. And we can use synthetic division from here. -4 times 2 is -8. -19 plus -8 is -27. -4 times -27 is going to be positive. 8. Carry the 2 is going to be 108. Times -27 is 108. We can add straight down. -24 plus 108 is going to be 84. -4 times 84. So minus 24 times -4. -336. And we can add 385 to it and get Now, can anybody quickly do what -4 times 49 is? And it's not so much knowing what it is, but we know that the remainder of this should be 0. So if we did this correctly, -4 times 49 should be -196. So that's one of our solutions. So we've taken it from a quartic, a degree 4, down to a degree 3. Let's use 7 to take it from a degree 3 to a degree 2. 7 times 2 is 14. -27 plus 14 is -13. 7 times -13 is going to be -91. 84 minus 91 is -7. And -7 times 7 is going to be -49. And doing some of these calculations, especially in the calculator, can sometimes be helpful, especially like the first one where we get these big numbers. So to make it a little bit easier to work with. So we got it down to a quadratic. Now at this point here, we could definitely use the quadratic formula to solve it, yes? But did we have any other zeros? 7 looked like it could work twice, yes? Now at this point we could stop because we do have ways to solve quadratics. But if I take it one more, we're taking it from a quadratic to a linear equation. Linear equations are even nicer. 7 times 2 is 14. -13 plus 14 is 1. 7 times 1 is 7. 0. So what we're left with is 2x plus 1 equals 0. We can subtract 1 from both sides, telling us 2x is equal to -1. Divide both sides by 2. And x is equal to -1/2. So way too much space. Put that up just a bit. So our other spot is, back. So our 3 spots are -4, -1/2, and 7. Now again, we didn't have to do this at the start, but the equation was already, everything was on one side and we had 0 on the other. Yes? Now for this problem, was it equal to 0? So yes, it was equal to 0, which means at these 3 points, well, apparently I'm going to scroll, they're going to be shaded in. They're going to be included. Because if we plugged in 7 for x, it would make a true statement. It would say that 0 is equal to 0. So it does work. But now we need what? Where this equation is what? Less than 0, yes? So we need the values of this here to be smaller than 0. And we did this, especially the first time. What we did next is I took testing points, points that we can check. So I could say -5, -2, 0, and we can say 10. So I picked points in the gaps, between the points and on either side, and to see which ones worked. And the first one that we picked was -5, yes? Is -5's y value 1,296 less than 0? No. So that means for us here, -5 is not part of the solution set. We can look at -2 next. And at -2, we get -486. That is indeed less than 0. So that value works. We can check 0 next. And at 0, we have 196. Is that less than 0? No. And lastly, we can check 10. Is 10 2,646 less than 0? No. So our solution set is all the points between -4 and -1/2, including -4 and -1/2, and 7. So in interval notation, this looks a little funny because we'd have -4, comma -1/2, both in brackets, union, braces 7. And the big difference between brackets, parentheses, and braces, brackets and parentheses is saying included, not included in the points between. Our braces are just those spots, just that individual point. So we're saying all the points between -4 and -1/2, including both, at the union of 7, so including the point 7. Questions on this here? Let's look at the next one, this one here. So here we're saying less than 0. Now again, just like with the previous one, we do need to get it to 0 by itself, so we have that. And we need our key points. Now the places where we'll have key points are where the numerator is 0 and where the denominator is 0. So we're going to solve both of these here for 0. X squared minus 25. Now, since there's no middle term, we can add 25 to both sides, telling us x squared is equal to 25. Then we can square root both sides, telling us x is equal to plus or minus 5. So we'll have 5 and -5 as our 2 points. Now we need to solve the other one, x squared plus 2x plus 1. Now we could use the quadratic formula, we could factor it, we could graph it, we can use any of these. So x squared plus 2x plus 1 graph. It intersects the x-axis at -1. Now, yes, x squared minus 25 does intersect the x-axis at +5 and -5. We could have graphed both of these and got our answer pretty quickly, or solved it either way. And it actually does work out. X squared plus 2x plus 1 has a solution of x equals -1 and x is equal to -1. That's it. Questions on any of this here? Circle, circle. Now, no matter how the equation's set up, 5 and -5 are always going to be open, no matter what the inequality sign is. Because at 5 and -5, that gives us a value of x that makes the denominator be 0. We can never have those. So even if it had been less than or equal to, 5 and -5 would still be open. It would just be that at -1 would be closed if we had equal to. Here, because it's just less than, all three are going to be open. Now we do need test points, so -6, -4, 0, and 6. And at this point here, we can plug each one of these in and see which one of these will make a true statement. At this point here, we can type it in, x squared plus 2x plus 1 over x squared minus 25. Now our first value that we're testing, I believe, is -6. And at -6, we get 25/11ths. So is 0 greater than 25/11ths? No. Next one we can look at is -4. Is -4 smaller than 0? Yes. The next one we can look at is 0. Is 0 less than, what is 0's value? -1/25, less than 0. Yes. And the last one we're going to check is 6. So again, we need it to be smaller than 0. Is it? No. So this is how our graph would look. Now, as an inequality, we'd have -5, comma, -1 at the union of 1, comma, 5. Or -1, comma, 5. Because we need parentheses around all of it because -5, -1, and 5, none of those are included. And we'd have this here. Now, if it had been less than or equal to, we could have just done -5 to 5 because -1 is included, so we'd have everything. Any questions on 18 or 19? And even if we look at the graph, less than 0 below the x-axis, what we can see between -5 and 5, it is below the x-axis. We just have to remove that one spot at -1. Divide by long division. Which one do you guys want to divide by long division? Doesn't matter which one. We can look at 21. Now the number outside is going to be our x squared minus 2x plus 3. The number inside, again, with long division, synthetic division, if there is one that's missing, we have to plug it in as 0. Since we have x to the 4th, we'll also need x to the 3rd. We don't have one. But we do have 3x squared. We don't have an x, so we have 0x plus 1. Anytime we're missing a term, we have to include it back in. Just move it over a little bit. Now our first main step is to see what we need to multiply x squared by to get x to the 4th to cancel. And that is just x squared. And off to the side, we can do x squared times x squared minus 2x plus 3. And if we multiply through by x squared, we get x to the 4th minus 2x cubed plus 3x squared. And we can put it underneath. And then we will subtract. X to the fourth minus x to the fourth is indeed 0, what we wanted. 0x cubed minus negative 2x cubed. The negative and negative will make a plus, giving us 2x cubed. 3x squared minus 3x squared is 0. Now, I don't think we specifically covered this, especially in class, but if one of them does become 0, I would write it in as 0. We still need that spot. Then we can bring the next one down, plus 0x. And we repeat the process again. We say what times x squared gives us 2x cubed. We need 2x. And it does work out that the variables are going to decrease in power by 1. So since we start out with x squared, the next one would be x, and the next one after that would be our constant term. Now we multiply x squared minus 2x plus 3 by 2x. 2x times x squared is going to be 2x cubed. 2x times negative 2x is going to be negative 4x squared. And 2x times 3 is going to be plus 6x. And again, once we get it set up, our next step is to subtract. 2x cubed minus 2x cubed is 0. 0x squared minus negative 4x squared. Negative and negative makes plus, so we get 4x squared. 0 minus 6x is negative 6x. And lastly, we bring down the plus 1. Last but not least, what times x squared is 4x squared? Plus 4. So now we're going to multiply the whole thing by 4, which will give us 4x squared minus 8x plus 12. And last but not least, we will subtract. Our 4x squared minus 4x squared is indeed 0. Negative 6x minus negative 8x. Well, the negative negative would make a plus. Negative 6 plus 8 is going to be positive 2x. 1 minus 12 is negative 11. Since we don't have any more terms to bring down, this would be our remainder. And we can add it to our answer. And we get this here. If the remainder is 0, we don't have to add it on. That's just going to be our answer. We only have to add that on if we have a remainder. Questions on this here? Now, luckily with long division, for like we get one before, we don't have to do anything if there's a number in front of the variable that goes first. So here, the 3x, we don't have to do anything to it. We can just go on and divide. Questions on any of this here? Now, if it was synthetic division, we would have to divide everything by that number. Do we want to look at 22 or 23? Because I think for the most part, we do feel comfortable with normal synthetic division like 22. So if we look at 23, the main issue we have with this here is that the number in front of x is 9. So to fix that, we've got to divide everything by 9. And when we do this here, what we're left with is x to the fourth plus 19 ninths x cubed plus 20 ninths x squared plus 11 ninths x minus 1 is being divided by x plus 1 ninth. Now the next thing we need to do is we need to solve x plus 1/9 for 0. Which is just negative 1/9. Now our numbers that go across the top are going to be 1, 19/9, 20/9, 11/9, and negative 1. And we bring the 1 down. Any questions on how we set this up? Now we multiply. Negative 1/9 times 1 is negative 1/9. On a calculator, we can say 18/9 minus 1/9 is 19/9. I got ahead of myself. (19/9) is 2, because 19 minus 1 is 18. 18 divided by 9 is 2. We multiply again. Negative 1/9 times 2 is negative 2/9. 20/9 minus 2/9 is, interestingly enough, 2. Negative 1/9 times 2 is negative 2/9. Again, we can say 11/9 minus 2/9 is 1. Negative 1/9 times 1 is negative 1/9. And then we can do negative 1 minus 1/9, which gives us negative 10/9. And that there would be our remainder. So we have this here. Questions on this so far? Now we do need to write this back out. So 10/9, negative 10/9 is the remainder. 1 is our constant term. 2 is our term with x. Our second 2 is our term with x squared. And our third is our term with x cubed. So we would say that we have x cubed plus 2x squared plus 2x plus 1 plus. Now we are going to have our remainder. Now, going from here to here, we did what? Divided by 9, yes? But we don't want to leave with this. We want to come back to this here. So the opposite of instead of dividing, we would technically multiply by 9. Because what we'll have as our remainder is 9x plus 1, what we started with. But to go from x plus 1/9 back to 9x plus 1, we had to multiply by 9, yes? Which means this remainder is also going to have to be multiplied by 9. And what is negative 10/9 times 9? Just back to negative 10. So whenever we do synthetic division and we had to divide to start with, whatever the remainder is, we just multiply what we divided everything by to get back to it. Even if it had been just negative 10, we would have still multiplied it by 9 and gotten negative 90. Any questions on any of this here? Vertical and horizontal asymptotes, and I believe that's it. Now, I did put on this here and the test, I did realize this. I did say to find the vertical, horizontal, and slant asymptotes for each function. Not every single function will have a vertical, horizontal, and slant. It won't have all three. Because Horizontal, if the degree of the top of the rational expression is bigger than the degree of the bottom, it won't have a horizontal asymptote, it'll have a slant. Vertical is just whatever is going to make the denominator be 0. So if we look at the first one here, because we can look at all three, 6 over x squared plus 2x minus 3. So our vertical asymptote is going to be whatever is going to make x squared plus 2x minus 3 be 0. And one of the nice ways to find that is, well, graph it. X squared plus 2x minus 3. X squared minus 2x plus 3. Have it flipped? Yes. It's just like, that would be very nice. Because if it was that way, we would have none. There wouldn't be one. But here, we do have two spots where it is 0. And those spots are at 1 and negative 3. So our vertical asymptotes are x is equal to 1 and x is equal to negative 3. Because vertical asymptotes are going to be x equals. It's going to be the line straight up and down. Horizontal asymptotes. This is going to be, again, going back to our theorems. If the degree of the top, so horizontal, if the degree of the top is greater than the degree of the bottom, there is none. This is going to be our vertical, our slant asymptote. When the degree of the top is bigger than the degree of the bottom, we have slant. When the degree of the top is equal to the degree of the bottom, it is leading coefficient over leading coefficient. When they're the same, it's leading coefficient over leading coefficient. And when the degree of the top is less than the degree of the bottom, it's our y equals 0. Well, here the degree of the top is 0, the degree of the bottom is 2, so the horizontal asymptote is y equals 0. And that's it. Because since we do have a horizontal asymptote, we won't have a slant. If we do have a horizontal asymptote, we won't have a slant asymptote. Questions on this here? Now, if we look at the next one, vertical is whatever is going to make the denominator be 0. So again, we can say 2x squared plus 5x plus 3 plus 5x plus 3. Yep. Graph. So does this cross the x-axis? Yes. Well, it does cross at one nice point, yes? -1. But it doesn't cross at a second nice point. We need two. We need both. So if we can do one of two things. One, we can use the quadratic formula. We could factor. Or we can use synthetic division. Because if we use synthetic division, I know one of the zeros is -1. 2, 5, 3. -1 times 2 is -2. 5 plus -2 is 3. 1 times 3 is -3, and we get 0. And what that leaves us with is 2x plus 3 is equal to 0. So one of the zeros was -1, and the other is negative 3/2. If we'd have used the quadratic formula, we would have found -1 and negative 3/2. If we factored, we would have gotten the factors to be, I'll write this up here, 2x plus 3 times x plus 1, which would have gotten us the middle term of 5. And then we get to set both of those equal to 0 and solved. Now 3/2 is a nice number, and it would be a little challenging on the graphing calculator, but we could go second trace and pick 0. So we want to go a little bit to the left, because if we keep going left, we see the y values become positive over here, and that's fine. So we can hit enter, go to the right, so we go below it. Enter one more time, we get -1.50, so that's the other 0. So we go to the left and right of it, crossing the x-axis. Horizontal. Now looking at this here, so this should be y equals. Now the degree of the top is 2, the degree of the bottom is 2. So we take the leading coefficient divided by the leading coefficient. Well, the leading coefficients are 7 and 2. So we'd have 7 over 2. Vertical asymptotes are going to be x equals something, if we do have them. Horizontal is going to be y equals. And even with slant, we will still have y equals that equation. Questions on 24 or 25? Now, as we've seen so far, most likely this one here is going to have a slant. Now, vertical is actually kind of nice. As we just need to see what's going to make x plus 9 be 0. And that would be -9. We could set it equal to 0, x plus 9 equals 0, solve by subtracting 9. We could have graphed x plus 9 and saw that it crosses the x-axis at -9. That is our vertical. Now, technically, horizontal the horizontal asymptote is none. We do not have a horizontal asymptote because the degree of the top is bigger than the degree of the bottom by 1. So what we actually have is a slant asymptote. Now, to find the slant asymptote, we need to divide these two. Now, we can divide them by long division. 5x squared minus 7x plus 8 is being divided by x plus 9. And if we do this here, what times x gives us 5x squared? That would be 5x, and we'd multiply it out. 5x times x plus 9 would be 5x squared plus 45x. And at this point, we would subtract. 5x squared minus 5x squared is 0. Negative 7x minus 45x is going to be negative 52x. We bring down the plus 8. Now at this point, we see what times x is negative 52x. That's going to be negative 52. So we have negative 52 times x plus 9. Negative 52 times x is negative 52x. And negative 52 times 9 is negative 468. And again, we would subtract. Negative 52x minus 52x is 0. Here the negative and negative make a positive, which gives us 476. Now we're not too concerned with the 476, the remainder for this here. We just want this here. So our slant is y equals 5x minus 52. So our vertical, x equals -9. Our slant is y equals 5x minus 52. Any questions on any of this here? So that is everything that is going to be on the test. Now, I will say this, you could have solved this here by synthetic division just as easily as long division and gotten the same answer.